Well, let's go ahead and see if we can rip this one out. Your Chapter 7, Algebra 2 Test Review. So the first thing we worked on was direct, indirect variation. If we're talking direct variation, it should fit the form y equals kx or equivalent letters. Indirect variation was y equals k over x. So this one, by nature of the plus sign, is neither. This one, you can identify that as k, and then it fits this form. So I would call this indirect. On number 5, the big thing is we got to locate two asymptotes. And I believe because I see no shifts, that one asymptote is at 0 height because we can't put a 0 on bottom. I believe another asymptote will end up being here because there's no shift left or right. But let's make a quick table just to check. If we put in 0, it's undefined. If we put in 1, we get 4 back. So 1 comma 4. If we put in 2, 4 divided by 2 is 2. We get 2 back. If we put in 4, we get 1 back. So it sure looks like our shape of this thing along here is going to go this way. Keep going. If we put in -1, we'll get -4 back. So if we want to go -1, -4. If we put in -2, we'll get -2 back. If we put in -4, we'll get -1 back. The only reason I chose the x's I did is because I was looking at things that would divide into 4 well so that I could graph them. It really wasn't a whole lot more than that. Okay, I believe, if I'm remembering what we went over right, +1 is going to shift my horizontal asymptote up 1. I believe this is going to shift my vertical asymptote to the right one. Well, that's not to the right. Why did they do that? So up 1, but looking at the scale of the thing. And then right 1. All right, now I'm going to go through and do a lot of the same things I was just doing. So x, y. If I plug in a 0, I'll get, let's see, -2 plus 1 is -1. So 0, -1. If I plug in a 1, it'll go undefined. If I plug in a 2, 2 minus 1 is 1. 2 divided by 1 is 2. I'll get a 3 back, I think. 2, 3. If I plug in a 3, 3 minus 1 is 2. 2 divided by 2 is 1. Plus 1 is 2. So 3 comma 2. So I'm guessing what we're seeing is there. And if we go a little bit the other way, say we put in a -1, 2 divided by -2 is -1 plus 1 is 0. So we're looking at -1, 0. So we're kind of looking like this. So it's really the biggest things that I'm looking for you to do is to be able to identify the shifts off the equation, shift right, shift up, and then generate a few points to figure out which one works. We didn't get real advanced in our graphing of this. So be able to do those two things. Okay. A little bit of the same stuff. So when we need to write the equation itself, And this is very much the form of how I wrote a couple test questions. First thing we need to do is find the k value, and then we can solve for x equals 2. So if these things vary inversely, then we're going to be using this formula. So when I go 4 varies inversely as 3, we solve for k and we get 12. We now know that our equation that we're working with is 12 over x. So that's the equation. That's step 1. Now we can plug in 2 and go y equals 12 over 2 and get 6. So we'll repeat that process with number 2. Y equals k over 4. Well, not y equals. Silly. Where are we at? Negative 2 equals. Times by 4, we get negative 8 equals k. That allows us to write this formula. Now when we plug in 4, or not plug in 4, plug in 2, y equals negative 8 divided by 2 equals negative 4. I believe those are what we're going for. Okay, so again, emphasis on the test is not a whole lot of generating your own graphs and points, but I want us to be there. But I want us to look at this and see in this general form y equals a over x minus h plus k, that we understand this is our left and right shift. And this is our up and down shift. This gives us some positive, negative, and growth in terms of what quadrants it's in. So I believe because this is negative, it's going to be in this quadrant and this quadrant. And because I see none of the h or k features, that I can write a vertical asymptote and a horizontal asymptote as so. So let's generate a few quick points that would work or be nice to our graph. Man, I hate when it does that. If we plug in a 0, it won't work. We plug in a 1, we'll get a negative 2 back. We plug in a 2, we'll get a negative 1 back. You can use your calculator to verify. So 1, negative 2, 2, negative 1. So it would appear to me that our graph's starting to go like that. If we plug in negative 1, we'll get 2 back. If we plug in negative 2, we'll get negative 1 back, or we'll get positive 1 back. Okay, your first Easter egg of the video. If on your test you put a star in the upper left-hand corner of page 1, you will get a bonus. All right, on to number 6. This tells me that I'm shifting left 1 opposite the sign, so vertical asymptote. This tells me I'm shifting down 1. This being positive tells me I'll be in the first quadrant and this third quadrant. So those are my expectations. Let's pick out some good graphing points. Okay, if I plug in a 0, 2 divided by 1 is 2, minus 1 is 1, 0, 1. Should work. If I plug in a 1, I should get a 0. So it's going to look something like this. If I plug in a negative 2, plus 1 is negative 1, I get negative 3, so negative 2, negative 3. If I plug in a negative 3, I get a negative 2 back, negative 3, negative 2. Now I got throw that down. All right, moving onward and upward. Which equation represents inverse variation? Inverse variation. So which can be manipulated to fit this form? Well, anything with a plus sign is out. There is no way that we're going to get to that form here. I mean, the easy answer is here. There's no way of manipulating that one. If x varies directly means y equals kx with the value of y. And y is negative 12 and x is 4. So again, this is that process where we got to solve for k first. Divide the 4 over and get that. So we can write this equation. Now all of a sudden we can plug in negative 3y equals negative 3 times negative 3. And we get 9. Let R vary directly with S and inversely with T. So directly with S would say R equals KS. And then inversely with T would be R equals K over T. So we can really combine it all that way. Now, it's semantics what letters you choose. So when I don't see any K's in all my choices, but I do see A's, then it must mean they're making their constant A. So I'm looking for there. Y varies inversely with the cube of x. This isn't something we've done a whole lot, but if we follow the inverse form from here, we'll figure it's like this. And then when it says cube of x, I just figure we got a cube x. Again, it's one of those cases like in number 3 where there is no k's. So it's really not a big leap to say, oh, they used a different letter for their constant term. Simplify the rational expression if possible. This is where we're going to test your factoring skills. So the first thing I'm going to look at is this becomes x minus 4, x plus 3. This becomes x plus 3, x plus 2. Then we look at this deal and see that those can cancel out. So my simplified version here is x minus 4 over x plus 2. Going to number 12, I factor this and I go x plus 3, x minus 3. I factor this and I get x plus 4, x minus 3. Cancel, leaving me with a simplified version of x plus 3 over x plus 4. And that's simplified. Okay, this next one, to save me some hassle, I'm going to do things like this. So divide by 7 is now 4. Divide by x now leaves this at 1x. Divide by x, those are gone. Divide by 3 is 2. Divide by 3, that's gone. Divide by y squared, this is down to y squared. Divide by y, that's gone. So by the time I do all that, I'm left with x and 4 on top, 2 and y on bottom. Ooh, I could go a little bit farther. 4 divided by 2 is 2. So I really should have went cancel by 2, and write it 2. Regardless. All right, I'm going to start by factoring and breaking things down. So x plus 5, x plus 2 over 2, x plus 2, x minus 2, difference of squares, times 4 over x plus 5. And you could write squared, but I think a lot of us would probably visualize it better if we turn that square into repeated multiplication. So what crosses out here? What cancels? Those. One of those takes 1 for 1. Divide by 2, divide by 2. And it sure looks like we're going to be at 2 over x minus 2, x plus 5. Okay, if you want another bonus point on the bottom right-hand corner of your test, you'll write Joey B. Baby. Okay, a lot of the same directions, just different problems. So let's get after it. Factor the top here. We got x plus 3, x plus 4. Factor the bottom here. X minus 3, x minus 4. Other than that, nothing's going to cancel. So really, I think this is already in a simplified form. This is where we'd say you grave error. So like, I'd want this to be a solution. I'd want the original problem to be a solution. The one thing that some people will be tempted to do is to go x squared cancels with x squared. 7x cancels with 7. You can't cancel. You're not in a position to simplify this thing. While these are trinomials, while there are 3 pieces disparately separated by addition, you must turn it into a multiplication problem a la factoring before we're in position to start simplifying, canceling, undoing division offered by the fraction. All right, so let's cancel this, or let's factor this. Let's factor this. Cancel. Looks like we're going to have x over x plus 1. And that's what we're going for. Can't go farther than that. All right, let's start that process of divide by 4. Divide by 4 is 3. Divide by 5. Divide by 5 is 6. Y cubed on bottom, 1y, 2 y's on top. X cubed on bottom, 2 x's on top, another x on top. 3 on top, divide by 3. So it really looks like to me we're going to end up at x over 2. You may have to rewind that one, watch it a couple times, see where the division's at. All right. This last one I am interested in. Before I start doing a lot of the canceling that I was just showing, I want to rewrite the problem a bit, because to divide fractions, it's easier to multiply by the reciprocal, which means multiply by flipping the second one, then start. So that's a real problem I'm going to consider. Now, if I divide by 7, I'm at 2. Divide by 2, this is at 3. Divide by y squared, this goes down to y. Divide by y, this goes down to y. Divide by x, this goes down to x squared. Divide by x, this goes down to x, and this goes away. So it looks like what we're messing with is 2x over 3y. Well, we're pumping along. Okay. I know at least in 5th period we've talked ad nauseum about factoring these cubes. You got the formula at the front of the board. You got to recognize it as a difference of cubes. So you got to recognize it as fitting this pattern. So I'm going to factor this thing as x minus 3 x squared plus 3x plus 9, and then have this still as x minus 3, cancel. And that's the answer I'm looking for. Okay, somewhere on your test, let's do this. On your test, on the back of it all, there'll be a big blank side, right? We'll end up writing this as a challenge problem up on the whiteboard. And then if you could show proper work and simplify this thing down, because it is an insanely great problem, I will give you credit. So you don't have to have the problem memorized, but I'm also not going to just show you the answer here. You got to be able to produce the work. What's really going to happen is this factors just a traditional factor. This factors as well, but not in quite the way where we just go, factor by grouping or pull out an X or anything like that. It doesn't factor like that. What we end up doing is going back a few chapters and using the fundamental theorem of algebra. And what that comes down to is we take factors of 21 over factors of 1, constant of leading coefficient. So we start looking at plus or minus 1, plus or minus 3, plus or minus 7, plus or minus 21. And then whatever those answers are will imply different factors. There'll end up being 3 parentheses that make this thing, and you'll be able to cancel a bunch of them. It'll come down to a really simple answer. So if you work it out, try it out, be prepared for it. I'll give you some major bonus points because this thing is insanely great. And I will give you commensurate bonus points for that. All right, over here, I'm going to rewrite this as a multiplication problem. Now I'm going to start canceling. It looks like I'm left with 3xy over just 4. It looks like. Awesome. Okay, on this last one on the page, I'm going to factor everything first to see if there's anything that cancels before we multiply. So x minus this one first, x minus 3, x plus 1 over 2, x minus 2, x plus 5, x minus 2, x plus 5, x plus 1. So before I start looking at multiply, I'll go boom, 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 and that makes our multiplication pretty easy. Boom. All right, moving on. What is the simplified form of this? So I'm going to just big brain factor this top There's only one way of multiplying, getting 2x squared, so I know if this thing's going to factor, I need 2x and x there. Now I'm just going to guess and check. So I got either 1 and 10 or 5 and 2 that need to work here, right? If I put a 2 here, my outer product, meaning this, is going to make 4x. My inner product, if I put the 5 here, is going to be 5x. And 5x and 4x have a chance of making 9x. So if I make that negative 5x, negative 4x, we'll make negative 9x by adding. At the same time, if I'm thinking about like foiling, negative 5 times negative 2 is still my positive 10. So I got a good factor. On bottom, if I go x plus 3, x minus 2, when you know that net cancel, I'm with 2x minus 5 over x plus 3. 2x minus 5 over x plus 3. Which expression is the product of all that? Whew. All right, divided by 13, I'm down to 3. Divide by 8, I'm down to 3. Divide by A, I'm at A. B, C, and a C go to C squared, and then C squared and C squared. Anything else? Doesn't look like it, so I'm looking at is 3 times 3 is 9. A times A squared is A cubed over B squared. Like when that's one of my options on the multiple choice, otherwise I would have been up a creek. All right, doing some more of the same. 2 divided by 2 is 8. 2 is 4. Divided by y cubed, y to the 5th, y squared, x cubed, x squared. So what I think I have on top is 4 and an x squared, and another x. So 4x cubed. And on bottom I have y squared is the only thing I have crossed out. So I think I'm looking at C. All right, on bottom here, do some factoring and write this out. So this again is the difference of cubes. So x minus 2, x squared plus 2x plus 4 times x squared plus 2x plus 4. From right here, the cool thing is this doesn't factor into binomials, but it's fine because this whole trinomial can cancel with this whole trinomial. So we're really just left with this, right? A. Okay, as much as it hurts your delicate sensibilities, you Brownies fans, if you write this up by your name, you will get a bonus point. All right, perform the indicated operation and simplify. Now we're getting into some real deal problems for the fact that we cannot perform this addition until we are in common denominators. So, get some of this out of the way so I have room. If we need to turn 3x squared into a common denominator with the other fraction, the only thing I see it missing is the 4. So if we multiply by top and bottom by 4, And then when we look at this 7 over 4x, I see it missing an x and a 3, so I need to multiply by 3x over 3x, which tells me then my top is going to be 8 plus 21x all over 12x squared. And then that can't be simplified. So on 18 here, this is more traditional in that we want to break it down into its parts first. So factor this. And factor this. What we'll see then is the right-hand fraction has 2x plus 2's. This one only has 1, so we need to introduce another x plus 2 into this problem right there. Then we'll see this left-hand one has x minus 2, and this does not, so we need x minus 2. And we'll go like that, which then allows us to know that our whole bottoms match. So this matches this, so we just get to recopy that. Right? Then we get to start looking at all this, and we have x plus 2 plus 3x minus 5, x minus 2. Now, I might go on a wild goose chase here, but I'm going to try it anyway. I'm going to multiply out the top to see if it factors back into anything worthwhile. So x squared plus 2x plus 3x minus 5, x minus 2. The thing you got to live with is this could very much be a waste of time, but we don't know. So if we make it 3x squared minus 11x plus 10 over x plus 2, x plus 2, x minus 2, that's just the bottom. Clean up the top a little bit. We have 4x squared minus 9x plus 10. We're still alive. X plus 2, x plus 2, x minus 2. So let's see if I can big brain factor this, see if that works out. 4 and 1, 10 and 1. Oh, let's just try. 2x and 2x is a way to multiply and get 4x squared. 5 and 2, let's see. That's 10. That's 4. That would never make 9. Let's try 2x. 2x, and then we'll try 1 and 10. So 10 and 1, so that'll make 20x. We're getting worse. You guys could also use the AC product here. I'm just not an AC product guy overall. Let's see, 10 and 1, 10 and 1, 5 and 2, 5 and 2, 2 and 5. So it really doesn't look like it's going to factor. So with that being said, I would have accepted probably this answer or this answer along the way. Take it for what it's worth. All right, gonna have to get rid of some of this, clear up some room. All right, by cross multiplying. The reason we get to cross multiply this next problem when we go to solve is because it's a fraction equals a fraction. So we get to say this times all of this, which makes it x times x minus 1 equals this times all of this. So 3 times 2x minus 2. So x squared minus x equals 6x minus 6. Get it all to one side. X squared minus 7x plus 6 equals 0. This one factors, so we have x minus 6, x minus 1, which means our answers are 6 and 1. Going on to 20, we'll have cross multiple of x plus 3, x minus 4, 6, x plus 1. Multiply this side out, we get x squared minus x minus 12, 6x plus 6, x squared minus 7x minus 18 equals 0. I think this factors as well. So ones we should definitely be able to do. Scrolling down. Do 21 first. See how much room I have. We cannot cross multiply as we did above because this addition sign is separating this problem into a binomial and therefore violating our cross products property. So what we need to do is get common denominators. So when we look at this problem, that's the first parentheses, second parentheses, third. So what I look across and see here is this particular one is missing the 2 over here. So if I make this 2 over 2, then what I can do is make this x plus 2 times x minus 6 all over 2 over x minus 2, set that equal to x over 8. I don't have to multiply the right-hand side and use the basic algebra theorem, because all I really did was multiply this one by 1. I'm setting myself up for a cross product later. So moving this problem on, x plus 2x minus 12, 2x minus 4 equals x over 8. 3x minus 12 over 2x minus 4 equals x over 8. So now what I'm going to do is set a cross product and go 8 times 3x minus 12 equals x times 2x minus 4, get 24x minus 96 equals 2x squared minus 4x. So 2x squared minus 28x plus 96. Give myself a little more room. Start to factor. Still believe it'll factor. C 4 and 12 maybe. So I really think our answers here are x equals 4 and 12. I'll leave it up to you to, for brevity of this video, to take 4, plug it back in here, 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 and here, and verify that the equation works. Then I'll leave it up to you to take 12, plug in 12 here, 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 and here, and see if it works. That's where you're checking for what's known as extraneous solutions. I'm not sure if any of these are extraneous or not, but I'm worried about how long this video is getting now. So, 22. What am I looking at? I'm looking at this one's missing a 2. This one's missing an x plus 4. Again, because I'm going to use cross products, I really don't need to change this side at all. As long as I get this side over the same common denominator. This one's also missing an x minus 3. So what I'm looking at is x plus 4 minus 4x, x minus 3. So now I got a problem where if I simplify it a little bit, clean up the top, x and negative 4x and negative 3x squared. This and this is going to be 16x over all of this. I'm now going to cross multiply. So 2x what I should really do is turn this top, pull an x, make it x, 3x plus 16. And I could have 4x, x minus 3, negative 3x plus 16. I could really probably divide that off of both sides. Divide 2x off of both sides. And have it down to this. I'm not sure we've necessarily done a whole lot like this anyway, so excuse me as I start to speed up the process on the steps that you may or may not follow along. I got 4. All right, what I'm going to do is end this video now, call this part 1, and I'll start at part 2.